A steamship, often referred to as a steamer, is an ocean-faring seaworthy vessel that is propelled by one or more steam engines that typically drive propellers or paddle wheels. The first steamships came into practical usage during the early 1800s. However, there were exceptions that came before. Steamships usually use the prefix designations of PS for paddle steamer or SS for screw steamer. As paddle steamers became less common, SS is assumed by many to stand for steamship. Ships powered by internal combustion engines use a prefix such as MV for motor vessel, so it is not correct to use SS for most modern vessels. History. The steamship was preceded by smaller vessels designed for insular transportation, called steamboats. Once the technology of steam was mastered at this level, steam engines were mounted on larger, and eventually, ocean-going vessels, becoming reliable, and propelled by screw rather than paddle wheels. The technology changed the very design of ships for faster, more economic propulsion. Paddle wheels as the main motive source became standard on these early vessels. It was an effective means of propulsion under ideal conditions but otherwise had serious drawbacks. The paddle wheel performed best when it operated at a certain depth. However, when the depth of the ship changed from added weight, it further submerged the paddle wheel, causing a substantial decrease in performance. Within a few decades of the development of the river and canal steamboat, the first steamships began to cross the Atlantic Ocean. The first seagoing steamboat was Richard Wright's first steamboat, Experiment. An ex-French lugger, she steamed from Leeds to Yarmouth in July 1813. The first iron steamship to go to sea was the 116-ton Aaron Manby, built in 1821 by Aaron Manby at the Horsley Iron Works, and became the first iron-built vessel ever to put to sea when she crossed the Channel in 1822, arriving in Paris on the 22nd of June. She carried passengers and freight to Paris in 1822 at an average speed of 8 knots. The American ship SS Savannah first crossed the Atlantic Ocean. The title of the first ship to make the transatlantic trip substantially under steam power is possibly the British-built Dutch-owned Curacao, a wooden 438-ton vessel built in Dover and powered by two 50-horsepower engines, which crossed from Hellevoetsluis, near Rotterdam on 26 April 1827 to Paramaribo, Suriname on 24 May, spending 11 days under steam on the way out and more on the return. Another claimant is the Canadian ship SS Royal William in 1833. The SS Archimedes, built in Britain in 1839 by British engineer Francis Pettit Smith, was the world's first steamship to be driven by a screw propeller. It had considerable influence on ship development, encouraging the adoption of screw propulsion by the Royal Navy. In addition to her influence on commercial vessels, the first steamship purpose-built for regularly scheduled transatlantic crossings was the British side-wheel paddle steamer SS Great Western, built by the great engineer Isambard Kingdom Brunel in 1838, which inaugurated the era of the transatlantic ocean liner. Screw propeller steamers. The key innovation that made ocean-going steamers viable was the change from the paddle wheel to the screw propeller as the mechanism of propulsion. These steamships quickly became more popular, because the propeller's efficiency was consistent regardless of the depth at which it operated. Being smaller in size and mass and being completely submerged, it was also far less prone to damage. James Watt of Scotland is widely given credit for applying the first screw propeller to an engine at his Birmingham works, an early steam engine, beginning the use of an hydrodynamic screw for propulsion. The development of screw propulsion relied on the following technological innovations. Steam engines had to be designed with the power delivered at the bottom of the machinery, to give direct drive to the propeller shaft. A paddle steamer's engines drive a shaft that is positioned above the waterline, with the cylinders positioned below the shaft. SS Great Britain used chain drive to transmit power from a paddler's engine to the propeller shaft, the result of a late design change to propeller propulsion. An effective stern tube and associated bearings were required. The stern tube contains the propeller shaft where it passes through the whole structure. It should provide an unrestricted delivery of power by the propeller shaft. The combination of hull and stern tube must avoid any flexing that will bend the shaft or cause uneven wear. The inboard end has a stuffing box that prevents water from entering the hull along the tube. Some early stern tubes were made of brass and operated as a water-lubricated bearing along the entire length. In other instances, a long bush of soft metal was fitted in the after end of the stern tube. The Great Eastern had this arrangement fail on her first transatlantic voyage, with very large amounts of uneven wear. The problem was solved with a lignum vitae water-lubricated bearing, patented in 1858. This became standard practice and is in use today. Since the motive power of screw propulsion is delivered along the shaft, a thrust bearing is needed to transfer that load to the hull without excessive friction. SS Great Britain had a 2 feet diameter gunmetal plate on the forward end of the shaft which bore against a steel plate attached to the engine beds. Water at 200 psi was injected between these two surfaces to lubricate and separate them. This arrangement was not sufficient for higher engine powers, and oil-lubricated collar thrust bearings became standard from the early 1850s. This was superseded at the beginning of the 20th century by floating pad bearing, which automatically built up wedges of oil which could withstand bearing pressures of 500 psi or more. First ocean-going steamships. The first steamship credited with crossing the Atlantic Ocean between North America and Europe was the American ship SS Savannah, though she was actually a hybrid between a steamship and a sailing ship, with the first half of the journey making use of the steam engine. The SS Savannah left the port of Savannah, Georgia, on May 22, 1819, arriving in Liverpool, England, on June 20. 1819, her steam engine having been in use for part of the time on 18 days. A claimant to the title of the first ship to make the transatlantic trip substantially under steam power is the British-built Dutch-owned Curacao, a wooden 438-ton vessel built in Dover and powered by two 50-horsepower engines, which crossed from Hellevoetsluis, near Rotterdam on 26 April 1827 to Paramaribo, Suriname on 24 May, spending 11 days under steam on the way out and more on the return. Another claimant is the Canadian ship SS Royal William in 1833. The British side-wheel paddle steamer SS Great Western was the first steamship purpose-built for regularly scheduled transatlantic crossings, starting in 1838. In 1836, Isambard Kingdom Brunel and a group of Bristol investors formed the Great Western Steamship Company to build a line of steamships for the Bristol-New York route. The idea of regular scheduled transatlantic service was under discussion by several groups, and the rival British and American Steam Navigation Company was established at the same time. Great Western's design sparked controversy from critics that contended that she was too big. The principle that Brunel understood was that the carrying capacity of a ship increases as the cube of its dimensions, whilst the water resistance only increases as the square of its dimensions. This meant that large ships were more fuel efficient, something very important for long voyages from across the Atlantic. Great Western was an iron-strapped, wooden, side-wheel paddle steamer, with 4 masts to hoist the auxiliary sails. The sails were not just to provide auxiliary propulsion, but also were used in rough seas to keep the ship on an even keel and ensure that both paddle wheels remained in the water, driving the ship in a straight line. The hull was built of oak by traditional methods. She was the largest steamship for 1 year, until the British and Americans' British Queen went into service. Built at the shipyard of Paterson and Mercer in Bristol, Great Western was launched on 19 July 1837 and then sailed to London. where she was fitted with two side-lever steam engines from the firm of Maudsley, Sons and Field, producing 750 indicated horsepower between them. The ship proved satisfactory in service and initiated the transatlantic route, acting as a model for all following Atlantic paddle steamers. The Cunard Line's Rms Britannia began its first regular passenger and cargo service by a steamship in 1840, sailing from Liverpool to Boston. In 1847, the revolutionary SS Great Britain, also built by Brunel, became the first iron-hulled screw-driven ship to cross the Atlantic. The SS Great Britain was the first ship to combine these two innovations. After the initial success of its first liner, SS Great Western of 1838, the Great Western Steamship Company assembled the same engineering team that had collaborated so successfully before. This time, however, Brunel, whose reputation was at its height, came to assert overall control over design of the ship, a state of affairs that would have far-reaching consequences for the company. Construction was carried out in a specially adapted dry dock in Bristol, England. Brunel was given a chance to inspect John Laird's 213-foot channel packet ship Rainbow, the largest iron-hulled ship then in service, in 1838, and was soon converted to iron-hulled technology. He scrapped his plans to build a wooden ship and persuaded the company directors to build an iron-hulled ship. Iron's advantages included being much cheaper than wood, not being subject to dry rot or woodworm, and its much greater structural strength. The practical limit on the length of a wooden-hulled ship is about 300 feet, after which hogging, the flexing of the hull as waves pass beneath it, become too great. Iron hulls are far less subject to hogging, so that the potential size of an iron-hulled ship is much greater. In the spring of 1840, Brunel also had the opportunity to inspect the SS Archimedes, the first screw-propelled steamship, completed only a few months before by F. P. Smith's Propeller Steamship Company. Brunel had been looking into methods of improving the performance of Great Britain's paddle wheels, and took an immediate interest in the new technology, and Smith, sensing a prestigious new customer for his own company, agreed to lend Archimedes to Brunel for extended tests. Over several months, Smith and Brunel tested a number of different propellers on Archimedes in order to find the most efficient design. A four-bladed model submitted by Smith. When launched in 1843, Great Britain was by far the largest vessel afloat. Brunel's last major project, the SS Great Eastern, was built in 1854–57 with the intent of linking Great Britain with India, via the Cape of Good Hope, without any coaling stops. This ship was arguably more revolutionary than its predecessors. It was one of the first ships to be built with a double hull with watertight compartments and was the first liner to have 4 funnels. It was the biggest liner throughout the rest of the 19th century with a gross tonnage of almost 20,000 tons and had a passenger carrying capacity of thousands. The ship was ahead of its time and went through a turbulent history, never being put to its intended use. The first transatlantic steamer built of steel was SS Buenos Aires, built by Allen Line Royal Mail Steamers and entering service in 1879. The first regular steamship service from the East Coast to the West Coast of the United States began on February 28, 1849, with the arrival of the SS California in San Francisco Bay. The California left New York Harbor on October 6, 1848, rounded Cape Horn at the tip of South America, and arrived at San Francisco, California, after a 4-month and 21-day journey. The first steamship to operate on the Pacific Ocean was the paddle steamer Beaver, launched in 1836 to service Hudson's Bay Company trading posts between Puget Sound, Washington and Alaska, long-distance commercial steamships. The most testing route for steam was from Britain or the east coast of the USA to the Far East. The distance from either is roughly the same, between 14,000 to 15,000 nautical miles, traveling down the Atlantic, round the southern tip of Africa and across the Indian Ocean. Before 1866, no steamship could carry enough coal to make this voyage and have enough space left to carry a commercial cargo. A partial solution to this problem was adopted by the Peninsular and Oriental Steam Navigation Company, using an overland section between Alexandria and Suez, with connecting steamship routes along the Mediterranean and then through the Red Sea. Whilst this worked for passengers and some high-value cargo, sail was still the only solution for virtually all trade between China and Western Europe or East Coast America. Most notable of these cargoes was tea, typically carried in clippers. Another partial solution was the steam auxiliary ship, a vessel with a steam engine, but also rigged as a sailing vessel. The steam engine would only be used when conditions were unsuitable for sailing, in light or contrary winds. Some of this type were built with propellers that could be lifted clear of the water to reduce drag when under sail power alone. These ships struggled to be successful on the route to China, as the standing rigging required when sailing was a handicap when steaming into a headwind, most notably against the southwest monsoon when returning with a cargo of new tea. Though the auxiliary steamers persisted in competing in Far Eastern trade for a few years, they soon moved on to other routes. What was needed was a big improvement in fuel efficiency. Whilst the boilers for steam engines on land were allowed to run at high pressures, the Board of Trade would not allow ships to exceed 20 or 25 pounds per square inch. Compound engines were a known source of improved efficiency, but generally not used at sea due to the low pressures available. Carnatic, a P&O ship, had a compound engine, and achieved better efficiency than other ships of the time. Her boilers ran at 26 pounds per square inch but relied on a substantial amount of superheat. Alfred Holt, who had entered marine engineering and ship management after an apprenticeship in railway engineering, experimented with boiler pressures of 60 pounds per square inch in Cleta. Holt had designed a particularly compact compound engine and taken great care with the hull design, producing a light, strong, easily driven hull. The efficiency of Holt's package of boiler pressure, compound engine and hull design gave a ship that could steam at 10 knots on 20 long tons of coal a day. This fuel consumption was a saving from between 23 to 14 long tons a day, compared to other contemporary steamers. Not only did less coal need to be carried to travel a given distance, but fewer firemen were needed to fuel the boilers, so crew costs and their accommodation space were reduced. Agamemnon was able to sail from London to China with a coaling stop at Mauritius on the outward and return journey, with a time on passage substantially less than the competing sailing vessels. Holt had already ordered 2 sister ships to Agamemnon by the time she had returned from her first trip to China in 1866. Operating these ships in the newly formed Blue Funnel Line, his competitors rapidly copied his ideas for their own new ships. The opening of the Suez Canal in 1869 gave a distance saving of 3,300 nautical miles on the route from China to London. The canal was not a practical option for sailing vessels, as using a tug was difficult and expensive, so this distance saving was not available to them. Steamships immediately made use of this new waterway and found themselves in high demand in China for the start of the 1870 tea season. The steamships were able to obtain a much higher rate of freight than sailing ships, and the insurance premium for the cargo was less. So successful were the steamers using the Suez Canal that, in 1871, 45 were built in Clyde's shipyards alone for Far Eastern trade. Era of the ocean liner. By 1870, a number of inventions, such as the screw propeller, the compound engine, and the triple expansion engine made transoceanic shipping on a large scale economically viable. In 1870, the White Star Line's RMS Oceanic set a new standard for ocean travel by having its first-class cabins amidships, with the added amenity of large portholes, electricity and running water. The size of ocean liners increased from 1880 to meet the needs of immigration to the United States and Australia. RMS Umbria and her sister ship RMS Etruria were the last two Cunard liners of the period to be fitted with auxiliary sails. Both ships were built by John Elder & Co. of Glasgow, Scotland, in 1884. They were record breakers by the standards of the time, and were the largest liners then in service, plying the Liverpool to New York route. RMS Titanic was the largest steamship in the world when she sank in 1912. A subsequent major sinking of a steamer was that of the RMS Lusitania. As an act of World War I, launched in 1938, RMS Queen Elizabeth was the largest passenger steamship ever built. Launched in 1969, RMS Queen Elizabeth II was the last passenger steamship to cross the Atlantic Ocean on a scheduled liner voyage before she was converted to diesels. In 1986, the last major passenger ship built with steam engines was the Fair Sky, launched in 1984, later Atlantic Star, reportedly sold to Turkish shipbreakers in 2013. Most luxury yachts at the end of the 19th and early 20th centuries were steam-driven. Thomas Ashton Smith was an English aristocrat who forwarded the design of the steam yacht in conjunction with the Scottish marine engineer Robert Napier.